is defined like in this relationship here, where S is complex number, okay, and we have a real part here, an imaginary part here, and this is the S-plane. We plot real versus imaginary. So if we have a function is equal 5 times the step function when delay is 0, then to find the Laplace, we take the integral from 0 to infinity, we substitute for ft here, and then we integrate, we end up with this e exponential to minus st times 5 over minus st, which is the antiderivative. And the answer is 5 over s, and this will be the Laplace transform of this function. The Laplace transform helps to solve linear differential equations and remaps from time domain in here to complex domain, or from time plane to S-plane. The Laplace has properties such as linearity, as you can see here. If we are given xt, then the Laplace is this over this region of convergence, ROC, from R1 crossed with R2. The delay t is t minus xt minus t, just like ut if we put the 5 here, t minus 5, and you remember the delay is shift in time from real time, then xs equal e to the minus st. So this one will become, if we add the delay, will become, if we put a 5 here, then the the Laplace will be 5 over s times e. We take the t, substitute instead of this one here, minus 5 s. Well, we have many properties. Differentiation, you took this in math class, integration, convolution, we mirror the signal and then multiply it by the system, and we get is we could say convolution in time domain is multiplication in frequency domain. Okay, so we take the Laplace of this plus the Laplace of x2, and we'll multiply them, and if we want to find them in time domain, we just take the inverse of Laplace. In MATLAB, we have SYMS where this t is the symbol of the function variable, and this t is the transform variable. So we have two variables. Simple, we have to define this first. And so if we have a function 5 delta t, like this way, then in MATLAB we have to write it as Heaviside, just like as written here. And then we multiply it by f, then the answer for f will be like this way if we just did not put semicolon here, suppress command. Then fs, the Laplace of f is Laplace, we put the function here, then the function variable here, then the transform variable here from the syntax. Okay? Just like the syntax in MATLAB, here we could find it as a Laplace f. We define 5 delta t قبل شوية, or we do it the other way, by another way is f transform variable, we just put s here, or Laplace f, then the function variable with the transform variable, but we have to use symbol sy s to define the variables. Just like here, SMS xy f equal 1 over square t Laplace f, and then we get the answer here. Well, if we go to MATLAB, then we paste this instruction. We have defined simple here, SMS, sym, st, function variable, s, control transform variable, then f as the delta t, 5 delta t here, we call it Heaviside MATLAB. Then we end up with we write Laplace, or fs equal Laplace of f t s, and then we end up with 5 over s, which is the one we have done by hand. Now we can do it this way, Laplace f without the variables, we end up with the same result. Or Laplace f s, and we end up with the same results. Now step function, we have to this is the step function. Derek is the delta function. So here is not Heaviside, is the step function, and Derek, let's put Derek with a delay, f Derek t, let's say, f equal Derek, which is the delta, t, this way, Laplace of f we end up with 1. Now if you put 5, Laplace f, we have Derek f equal 5 times Derek, which is the delta, Heaviside is the step, t, okay, let's see if we try it with -3 as for delay. Let's work that way. Okay, now we see what happened to the delay. Laplace of f. Let's see where the delay comes out. Well, yes, here's the delay, but this exponential relationship when it comes over up, it will have a negative sign, just like the delay of, for example, have a side F equal AV I SID, and what do we want to reach time here? XT minus 5. Okay, and we want 5 here. If you see this, times, and see how it deals with the delay, and Laplace of F, well, here it is, just like the answer we have done the example. This one is the Heaviside, the step function, which is the step function, just like this way. T ut. And this is the delta function, which is this way. Well, we can do many things with this for any function. What about the ramp function? Ft equal t, which is the ramp function. So we go back to MATLAB. And what CLC, clear all. So then we start from the beginning. F equal T, and then Laplace of T. Now we got the function variable. No function, just put the function variable and the function variable transform variables من عنده بهاي الحالة فيطلع 1 over s squared, which is match if you integrate it by hand. I mean, if you look at the table. Okay, thank you.